Hello. Today we're going to be talking about two-dimensional figures. Let me grab my pen. All right. We're going to talk about the names of different polygons, triangle, quadrilateral, etc. And look at the perimeter, circumference, and area of these two-dimensional figures. So I'm going to just go through these vocab real quick and see what we got. Okay, these first four I will explain, I believe, on the next slide. The n-gon, I'm going to pull up something for you to copy or, ooh, there we go. So as you know, a polygon, a three-sided is triangle, probably know a four-sided is quadrilateral, and so forth. I don't think I have this chart in your notes, so you might want to pause it and copy it down, at least the ones that are hard to remember. I'm going to explain that the after 9 sides, which is a nonagon, it's okay to call it an n-gon. So if it's 10-sided, it would be a 10-gon. If it's 20-sided, it would be a 20-gon. Okay. But I also wrote the decagon, hendecagon, and dodecagon because those are very common to name the 10, 11, and 12, and you might see those in your book, the names in your book. So I wrote those as well. Okay, I'm going to go back to our PowerPoint. And there. So an equilateral polygon means it has the same, all the sides are the same length. Equiangular means all the angles are the same measure. A regular polygon means that the sides, the equilateral, and the equiangular, the angles, apply. So regular polygon has all sides the same length and all angles the same measure. Perimeter, you guys know, you add up all the sides. Circumference, that's the perimeter of a circle. Area, all right, I think we're good on that. So a polygon is a closed figure formed by a finite number of coplanar segments called sides, okay, such that the sides have a common endpoint. That's called your vertex right there, where your sides meet. And each side intersects exactly two other sides, but only at their endpoints. What that means is you can't have a figure like, whoops, I was going to make kind of an X inside a square. You can't have them crossing like that. So the vertex of each angle is the vertex of the polygon, and it's named by the letters of its vertices. So this polygon would be polygon GHJKLM. And it really doesn't matter where you start naming it. You could start it at K or L, J, does not matter. But you need to go in order. So it doesn't matter if it's clockwise or counterclockwise. But, I keep writing. It could be polygon HJKLMG. Okay, that is fine. Also, they're straight sides. There's no curves. So a common one people like is a heart, your shape of a heart. People sometimes forget that that's not technically a polygon. Or a circle. Circle is not a polygon. Okay. So we need to talk about convex or concave. So if you have a polygon that is concave, it does not go inward. So this one here is concave. Concave would kind of look like that, where it kind of caves in. Okay. If it's convex, then it doesn't, as you go through, follow the sides, it doesn't ever go in towards the interior of what you would think the polygon is. Okay. So a regular polygon, like I said, is equiangular and equilateral. And a regular polygon is always convex. I would write that down. Regular polygons are always convex. Okay. Now, if something's convex, it doesn't mean it's regular. But if it's regular, it is convex. So let's name this one. This one has 4 sides, so we got a quadrilateral. So I'm just going to write quad. And it is convex. So convex. And it is irregular. We'll just call that All right. Here's another one. So if we count up the sides, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that is a nonagon. It is concave because, as you can see, these kind of go inwards. And it's irregular because we have different sized sides and different angles. And so there we go. Nonagon, concave, irregular. All right, I'll let you do this one. You can pause it real quick. Okay. Well, it's a triangle. It's convex and it's regular. It's equiangular and equilateral. So it's definitely convex. Here's another one. Well, it's a quadrilateral and it is convex, but it's not regular. Okay? If you note, all the sides are the same, but your angles are not the same measure. So here and here, not the same. This is in your notes, and it's nice to have handy in case you kind of forget, oh, what's the area of a triangle or whatnot. So they use you can use any of these, whatever you're comfortable with. Okay, so we're going to find the perimeter of this and the area. So perimeter, you're going to add up all the sides. Area, you're going to multiply length times width. I'll show the answer. So the perimeter is 13.8. You just need to add 4.6 plus 4.6 plus 2.3 plus 2.3. The area is 10.6, I guess, because they rounded to the 10th, centimeters squared. Don't forget that the labels on area, you have to have the squared. So that's just 4.6 times 2.3. All right. Your circumference of a circle, I don't know where I'm writing it. There we go. So your circumference is pi, diameter times pi. So in this case, the diameter is twice as long as the radius, so we're going to have 8 pi. Now, if you put this in your calculator, you're going to get a decimal. You can give me the decimal, or you can give me just the exact answer of 8 pi inches. Okay, I'm sure that'll come up here. They use 2 pi r, which is fine. And then they give a 25.1 as the decimal approximation. That is fine too. I think in my answer book I have both written. So either way. The area now is pi r squared. So this time your r is 4, so you need to square it. That's 16, so it's 16 pi. And it's inches squared. Oof. There we go. Which they say is about 50.2. But again, you can leave it as that 16 pi inches squared. That is totally fine with me. All right, I'll let you do this one. So go ahead and pause it. Okay. All right, perimeter, you're just adding the sides. Area, you're multiplying length times width because this is a quadrilateral, nice rectangle looking thing. I'll let you do a circle. Okay. So we have about 50.3 meters for the circumference and 201.1 meters squared for the area. I don't think I'm doing this question. Okay. Okay, here we go. Each of the following shapes has a perimeter of 88 inches. Which one has the greatest area? Okay, so if you want to pause this, you'll have to go through and find the area of each of these and then figure out which one is the largest area. So go ahead and pause it and then come back for the answer. All right, you should have found that a circle with a radius of 14 inches ends up having the greatest area. I don't have it written out what it is, but you can double check with each other. Okay, that is actually where we're going to stop. We will do this stuff on the coordinate plane, but later we'll do lots of it, so we don't need to do a whole lot of it right now. I think I'll end the video there, and good luck, and I will see you on Monday.